Hi, Algebra 2. This is Mrs. Cowles, and today we're going to take a look at Properties of Parabolas, Lesson 5.2. Our objective today is to graph quadratic functions and find the minimum and maximum values. We have been learning that standard form of a quadratic function is f of x equals ax squared plus bx plus c. Today we're going to take a look at what happens if our b value is equal to 0. Well, if we think about that, if we plug the b value of 0 into our function, what's going to happen here is we're going to have 0 times x. 0 times anything is going to become 0, and that's going to go away, and all we're going to be left with is f of x equals ax squared plus c. So when our b value is equal to 0, the linear term will go away, and we're going to be left with f of x equals ax squared plus c. This is still a quadratic function, so the graph of f of x equals ax squared plus c is going to be a parabola. Okay, it's still the second highest degree is 2, so it's still quadratic. The graph is still going to be a parabola. And it's going to have an axis of symmetry of x equals 0, where the vertex of the graph is going to be 0, c. Okay, so if that linear term has a b value of 0 and it cancels out, we are going to be able to find our vertex by looking at our constant term. This will be the y value of our vertex, and it's going to be 0, c. The c value will also be the y-intercept. So when we look at this, this will also be the y-intercept. It's where the graph will cross the y-axis. From that y-intercept, we know that that's going to be where our vertex is going to be. So the ordered pair will be 0, c. And from our vertex, we know the axis of symmetry goes through our vertex. It's equal to the x-coordinate of our vertex, x equals 0. So let's take a look at this first example where we have y equals x squared, and I want you to graph it. So if we think about this, y equals x squared can actually match up into the form y equals ax squared plus c. Our c value in this case would be equal to 0. So I know right now that my y-intercept of my graph is going to be 0. So if I was even just to go over here and plot that, there's my y-intercept. Now we also see that this is going to be the y-coordinate of our vertex. Our vertex is going to be 0, 0, or 0, c, which is 0, 0. Now our axis of symmetry, we can draw that in our graph. We know it's the vertical line that cuts our parabola in half, and it's going to go right through our vertex, 0, 0. So our axis of symmetry would have the equation x equals 0. So just from looking at the equation, I can identify the vertex, the y-intercept, and the axis of symmetry. So to start graphing, the first thing we do is we graph our vertex. Then I think it's a good idea, after you graph your vertex, to draw in your axis of symmetry and have it labeled x equals 0. So step 1, graph the vertex. Step 2 is we're going to make a table of values, and we're going to find some points on one side of the axis of symmetry. So we're going to make a table of values, and I'm going to go ahead and put in my vertex. My vertex was 0, 0 in this case, and I'm going to plug in some points to one side of my vertex. So I tend to like to go to the right, towards the positive side. So since my vertex is 0, 0, I'm going to plug in 1 and 2. They're to the right side of my axis of symmetry or to the right side of my vertex. So we're going to plug those values into our equation, y equals x squared. So this would be y equals 1 squared, and we would be equal to, have an equal value of 1. And then we would plug in the 2, and we have y equals 2 squared, which gives us a value of 4. So you're going to go ahead and you're going to graph these points on your graph. So we're going to plot 1, 1, and 2 and 4. So I will go over here and do that, 1, 1, 2, and 4. So that is step 2. Now, step 3 says graph the corresponding points on the other side of the axis of symmetry. So all you're going to do now is go ahead and take the points that you graphed to the right and graph their corresponding points to the left by reflecting them over your axis of symmetry. Once you have them reflected, you will go on to step 4 and sketch your curve. So we're just going to go through and sketch our points of our parabola. Okay, so you can pause the video and try the next one on your own and see how you did, or just continue to work out this next example with me. So now I want you to go through and I want you to graph the equation y equals 2x squared minus 4. So we see that we have no linear term in this quadratic. So if we think about it, it's y equals 2x squared minus c. We know our c value right here is our y-intercept. So we know that the y-intercept is going to be at -4. From that, we know that the vertex will be 0, -4. Because again, if it's our y-intercept, we know that it's going to have an x-coordinate of 0. So I'm going to go ahead, I got my vertex, I'm going to plot that, 0, -4. Slide this up a little bit. So 0, -4. And then after you plot your vertex, you should go through and you should draw in your axis of symmetry. You put a dashed line. And then you should label your axis of symmetry. My axis of symmetry is the equation x equals should be x equals 0. And there we go, because it's equal to the x coordinate, and because all the x values are the same. Okay, so you have your axis of symmetry. You got your vertex. Now you're going to go ahead and you're going to go on to step 2, and you're going to make a table of values for x and y. And then you're going to go through and you're going to put your vertex in there. We have 0 and -4. And you're going to plot several values to one side of your axis of symmetry of x equals 0. So again, I like to choose the positive number, so I'm going to plug 1 and 2 in for x, and then we're going to go ahead and calculate that out. So I have y equals 2 times 1 squared minus 4. 1 squared is 1 times 2 is 2. 2 minus 4 gives me a -2. So I have 1 and -2, and then I'm going to plug in a positive 2 in for x. So I'll have 2 times 2 squared minus 4. 2 squared is 4. 4 times 2 is 8. 8 minus 4 will leave me with 4. And now go over to your graph and you will plot those two ordered pairs. So I have 1 and -2, and then I have 2 and 4. And the last step now is to go ahead and graph its corresponding points on the other side of your axis of symmetry. So you're going to go ahead and you're going to reflect them over, and then you will sketch your curve. Okay, so that is page 1. Okay, so now let's take a look at what happens when we have our equation in standard form and our b term does not equal 0. So if we have our quadratic in standard form and the b term is not equal 0, the values of both a and b are going to affect the position of our axis of symmetry. So in standard form, f of x equals ax squared plus bx plus c. When a is greater than 0, meaning when a is positive, it should tell us that our parabola is going to open up. Okay, so our parabola will open up, and when it opens up, that means if I look at my vertex is going to be a minimum. But when a is less than 0 means negative, the parabola will open down, and if we think about when our parabola opens down, our vertex is going to be a maximum. To find the x-coordinate of the vertex when b is not equal to 0, we have a formula that says the x-coordinate of the vertex will be the opposite of b all over 2 times a. To find the y-coordinate of the vertex, we will substitute the x-coordinate that we find into the equation. So in order to find the full vertex, we are going to find the x-coordinate first by taking the opposite of b all over 2a, and we're going to find that value, and then we're going to plug it into our function. So we'll do f of opposite of b all over 2a, and that output will be the y-coordinate of the vertex. Okay, so we'll find it by substituting that x-coordinate into the equation. So since our axis of symmetry is equal to our x-coordinate, the axis of symmetry is going to be the line x equals the opposite of b all over 2a. That will be the axis of symmetry line. The y-intercept will still be equal to our c-coordinate, our constant c. So the y-intercept is going to be equal to 0, c. So that has not changed. This up here will still be the y-intercept. It's just no longer the vertex when it's in this form. Okay, so you can see, take a look at everything that we talked about. These are two pictures that go through, and everything that we've drawn up here, it goes through and shows the pictorial form of y equals ax squared plus bx plus c. When a is positive, it opens up, has a minimum. Opposite of b over 2a is the x-coordinate of our vertex, and then we plug that value in to get the y-coordinate. And here we see a picture when a is less than 0, meaning it's negative, it's going to open down, and our parabola will have a maximum at the vertex. Okay, so let's take a look at example 3. It says, graph the function, label the vertex and the axis of symmetry, find the maximum or minimum value, find the maximum or the minimum. So let's take a look at our function. As we start to take a look at this, we see in our first equation right here, we see that our a term is negative. We see a is less than 0 because it tells us it's negative. So we know from a being less than 0, our graph is going to open down and that the vertex will be a maximum. Okay, so in order to answer this question, to go through and answer each step, it's helpful to identify your a, b, and c term. So our a term is -1, our linear term b is going to be 4, and c, our constant, is 2. So we know the graph is going to open down, meaning our vertex is going to be a maximum. Let's go through and we're going to find and graph our axis of symmetry. So to find our axis of symmetry, we're going to use the equation x is equal to the opposite of b all over 2a. Usually when I write this, I put the b in parentheses. It doesn't matter. You just want to make sure if you have a double negative, you know it's going to cancel to a positive. So let's try this. X is equal to the opposite of 4 all over 2 times a, which is -1. When we write that out, we're going to end up with -4 over -2, which is equal to 2. So we know that our axis of symmetry is going to have the equation x is equal to 2. That is our axis of symmetry right there. So now that I know my axis of symmetry, I can actually go through and find the vertex as well. To find the vertex, we know that the x-coordinate is going to be 2 because that's our axis of symmetry. So we're going to plug the x value in from that step above, and we're going to plug it into the original equation to find the y value of our vertex. So we're going to go ahead and we're going to do f of 2, and we're going to plug that in. So it's a negative, and then in parentheses I put 2 squared, plus 4 times 2 plus 2. That becomes the opposite of 2 squared, which is the opposite of 4, plus 8 plus 2, and when we work that out, -4 plus 8 plus 2 is going to be 6. So f of 2 is equal to 6. So our vertex is going to have the x-coordinate of 2 and the output of 6. So we find our axis of symmetry, we use that x-coordinate to find our vertex. Now we're going to go ahead and we are going to plot that on our graph so far. We're going to plot 2 and 6 for our vertex. We're going to draw in our axis of symmetry. So my AOS, I'm going to label that as x equals 2. And now we need to find another point. So to find another point, we know the y-intercept is our c value in our equation, is our constant. So if I go back and take a look at our equation at the top has a c value of 2. So we know our y-intercept is going to be at 2. So the y-intercept is going to be at 0, 2. I'm going to go ahead and plot that on my graph. So 0, 2. And now once you have the y-intercept, you can reflect that over your axis of symmetry. to have another point, and there you go. You have 3 points. You can go ahead and you can sketch your curve. Now, if you wanted to find more points, you could have set up a table and continue to plug in a couple points and reflect them over. But for now, we're going to use our vertex, our y-intercept, reflect it over, and sketch our curve. Now, as we continue to look at this problem, it did ask us to find the maximum or minimum. We know that the vertex was a maximum. And we take a look at our vertex, and the vertex was at 2, 6. I'm going to label that on my graph. And not only is it a maximum, but we can actually state what the maximum height is. The y-coordinate of your vertex will tell you the maximum or minimum value of our graph. So when I take a look here, I can see that it lines up. My maximum height is going to be at 6. So when I look at this, my maximum value of my graph will be equal to 6. Okay? So when we take a look at the last page here, it tells us that the y-coordinate of the vertex of a parabola represents the maximum or minimum value of a quadratic function. So the x-coordinate tells us what our axis of symmetry is when we have our vertex. The y-coordinate of the vertex will tell us the maximum or minimum value. So you can pause the video and try this next equation on your own, or just continue to follow through. So it says graph and find the minimum value of the function f of x equals 2x squared plus 8x minus 1. So step 1 is to identify the a, b, and c. We have a is equal to 2, we have b is equal to 8, and we have c equal to negative 1. So by looking at this equation, if I take a look at my a value, I see that my a value is positive, so I know right away by looking at this, I know the graph is going to open up. So if I look at this and did a quick sketch, when I'm all done, I know my graph should look like that, and it's going to have a minimum value. Okay, so let's start to find our vertex. You do have to memorize and know the formula to find the vertex, and we're going to start by finding the x-coordinate, which will give us our axis of symmetry, opposite of b, all over 2a. So that's opposite of 8 all over 2 times 2, so that's negative 8 over 4, which gives us negative 2. So from this, we know our axis of symmetry has the equation x equals negative 2. Now I want to find the y-coordinate, so I'm going to go ahead and plug in negative 2 into my function. F of negative 2 is equal to 2 times negative 2 squared plus 8 times negative 2, and then I have a minus 1. You can go ahead and use your calculator, do the math in your head, but the answer to that will be negative 9. So my vertex, we can now label, has an x-coordinate of negative 2. It has a y-coordinate of negative 9. So I now have my vertex, which we can now plot. I also have my axis of symmetry. So we will plot those in just a second. But we are going to need a third point, and one of the points that we learned is our y-intercept is equal to our c value. Our y-intercept is 0, c. So when I go ahead and take a look, my c value was negative 1. Our y-intercept will be 0 and negative 1. So we're going to go ahead, we're going to plot our graph. Our vertex is at negative 2 and negative 9. So we'll go over to our graph and we're going to plot that, negative 2 and negative 9. You should draw in your axis of symmetry. Anytime you quiz on this, they're going to ask you to draw in your axis of symmetry. So you should get in the habit now of drawing it in and labeling your axis of symmetry. X equals negative 2. And from that, we then found our y-intercept of 0 and negative 1. So we'll plot that. And then we're going to go ahead and reflect that over. And we can do a quick sketch of our graph. All right, so not the best, but it's good enough. It does ask you to identify the minimum or maximum. We know it's going to be a minimum, and a minimum will be equal to our y-coordinate. So our minimum value is at negative 9. Okay. Okay, so let's take a look at example 5. The number of items a company sells frequently is a function of the item's price. The revenue from sales of the items is the product of the price and the number sold. So I'm going to underline it. The revenue from the sales of the item is means equals to. Okay, so the revenue is equal to the product of the price and the number sold. So all I got to do is multiply the price and the number sold to calculate the revenue. The number of unicycles a company sells can be modeled by negative 2.5p plus 500. So this is the number of unicycles a company actually sells, and we can model it by negative 2.5p plus 500. What price will maximize the company's revenue from unicycle sales? So we want to figure out what price will give the company the most revenue. Okay, so that's what we're trying to figure out. What's going to maximize the company's revenue from unicycle sales, and then we're actually going to calculate what that maximum revenue is. All right, so let's start to take a look at this. Here it says revenue equals the price times the number of unicycles sold, okay? Because it told us up here that revenue is the product of the price and the number sold. So we're talking about the number of unicycles sold. So revenue is equal to our price times the number of unicycles sold. And we were told in this problem that the number of unicycles sold is equivalent to negative 2.5p plus 500. So I'm going to do the price P times negative 2.5p plus 500. So I just interpreted it how to calculate the revenue. Okay, so now that we have that, we're going to go through and we're going to simplify that down here. So we're going to distribute the P through, and we are going to be equal to revenue is equal to negative 2.5p squared plus 500p. Now if we take a look, revenue is a quadratic function. We see that our A value is negative, so we start to know in our head that if we were to graph it, it's going to have a parabola shape. And we see that our vertex is going to be a maximum. And that's where we're going to be able to find the maximum revenue. So if we take a look, our ordered pairs, instead of x and f of x, we're using P as our input and our output is R. So it's going to be price, comma, revenue. So the question says, what price will give us the maximum revenue? So we're going to be trying to find our vertex in order to answer that question. So we're going to start by identifying our A term is negative 2.5, our B term is equal to 500, and obviously our C term, I should go back and take a look at that. Yes, our B term is 500 and our C term is our constant, which would be 0. So let's go ahead and find the x coordinate of our vertex, opposite of B over 2A. It's something that you need to memorize. So the x coordinate, which is P, is the opposite of B, so it's negative 500 all over 2 times negative 2.5. So we're going to go through and work that out. That's negative 500 over a negative 5, so that becomes 100. And since it is our price, I'm going to put the dollar sign out in front. So right now for our vertex, the x coordinate is going to be 100. Now we can go ahead and we can calculate the max revenue, R, by going ahead and plugging the 100 in. So we're going to have R is equal to, and we'll plug that in, our price was going to be, we said it was $100. Okay, so here's our function over here. So we're going to do negative 2.5 times 100 squared plus 500 times 100. We took the 100 and we plugged it in for the price. So you'll use your calculator and you'll go ahead and you'll type that in, and it's going to equal 25,000. So if I was to go back over to my vertex here, my output would be 25,000. So now to answer the question says, what price will maximize the company's revenue? Well, that price will be $100. So we will answer a price of $100 will maximize company's revenue. And then it says, what is that maximum revenue? The max revenue will be $25,000. So anytime you are asked with a quadratic model and they're asking you to find maximum or minimum values, you should know that in a quadratic model, the maximum and minimum values are going to occur at the vertex. So that should be assigned to you when interpreting these context problems, that you're going to take that model and you're going to go through and find the coordinates of the vertex in order to answer those questions. So you can try example 6 by pausing the video, or you can just continue to watch and see if you just need more guided practice. But if you think you can do it on your own, pause it and then see if you come up with the correct answer. All right, so let's take a look at the last example. It says the equation for the motion of a projectile fired straight up at an initial velocity of 64 feet per second is h is equal to 64t minus 16t squared, where h is the height in feet and t is the time in seconds. Find the time the projectile needs to reach its highest point and how high will it go. Notice, we're trying to find the time when it's going to reach its highest point. Its highest point is going to be at its maximum. And if we go back and we take a look at the function that models the height in terms of time, we see it is a quadratic function. It's just not written in standard form. So that's the first thing I'm going to do is I'm going to go ahead and I'm going to rewrite that as negative 16t squared plus 64t. Now from this function, I see that it's going to open down, meaning the maximum height is going to occur at the vertex, and the ordered pair of my vertex is going to be t comma h. We're not using x and y, we're using t and h, and t is the input, h is the output. So find the time, that's the x coordinate of our vertex, that it's going to reach the highest point. So you should know your formula to find the x coordinate of your vertex. It's opposite of b over 2a. Well, my a value is negative 16. My b value is equal to 64. So to find my time, the x coordinate of my vertex, it's going to be the opposite of 64 all over 2 times negative 16. So that's going to be negative 64 over negative 32. And when you divide that out, you should come up with 2. So right now, I see that the time is going to be 2. Okay, and I believe they measured the time in seconds if we go back and take a look. So the time is 2 seconds. So we'll put our units in with that. Now we can go ahead and we can find the height by taking our 2 and plugging it into our original function. So we're going to have negative 16 times 2 squared plus 64 times 2. So you'll go ahead and type that into your calculator, and when you do, the output will be 64. And we see that the height from our equation is measured over in feet, so we're going to put 64 feet. And then we're going to answer the question. Find the time the projectile needs to reach its highest height. So the projectile will reach the max height at 2 seconds, and the max height is 64. So we're going to say the projectile will reach its max height of 64 feet at 2 seconds. Okay. All right, so this is the end of lesson 5.2. When you're done with these notes, you should go back and you should take a little bit of time and you should summarize the main ideas. Again, the main ideas are determined in the objective. Our goal is to graph a quadratic function. So you should summarize what it takes to graph a quadratic function. You should summarize information about what it means if it's the b term for your linear term is equal to 0. How does that affect the graph? Where is your vertex going to be? What does the c represent? You should also go through and summarize the formulas for how to calculate axis of symmetry, opposite of b over 2a. Okay, you want to go through and talk about that. Make sure you understand and know those formulas. Know how to use that to find the y-coordinate of your vertex. You should also summarize the vertex is related to the maximum and minimum, and that the y-coordinate of the vertex will tell you where your maximum and minimum height. If you are able to do those things and understand them without looking back at your notes, you are getting strong with the concepts for this lesson. Okay, Algebra 2, have a great night.